Hi, in this video we'll talk about linked list. So in the previous videos we were talking about how to make stack and queue and lists out of array. Okay, but today we will learn a new concept. It's called linked list. This linked list consists of nodes like node A, node B, C, D, E, and every node is pointing to the next node in the list. So we have kind of sequence. We call the first node as a head and the last node as a tail. So the advantage of the linked list is that we can add and remove. They are efficient operation. Add and remove are efficient operation. And the linked list is dynamic, like there is no limit, there is no fixed size like in the array. So we can add elements as much as we want. There is no limit for the addition. The disadvantage is that we cannot use set and get like in an easy way. They are not efficient. So let's talk about something first called singly linked list. The singly linked list, every node points to the next node. Like A is pointing to B, B is pointing to C, and so on. The last node points to null, just to mark this is the end of last node is not pointing to anything. We have head pointing to the first node and tail pointing to the last node. And also we keep track of the number of the elements in the linked list. So how to implement the linked list? We'll create a class called node. This is just a class, complete class, public class node. This node has two things: the data that we want to store in the node and a pointer to the next node. As we saw before, every node has two things: the data, A, and a pointer to the next node. So we call this node next. And the linked list has head and tail, and we store the number of elements we had. So let's start making stack as a linked list. So in the stack we can make the push operation and the pop operation in the linked list. Let's try to implement it in the code and then we come back to the slides. So to implement this, we create new project, Java application. Let's call it linked list demo. So in this project, we'll create a class called node. So in this new project, we'll create a class called node. So the name is linked list. This one. So here, this is the main class. We'll create a class called node. This is very simple class. We just will have in this class two fields. The first one is just the data object. Let's call it data. And the next is a reference to the next node, node next. So this is just a pointer to the next node and it will be of type node. So this is the node class. After that we will create new class called linked list. In this class we will have as a field three things. We will have the head, which is the first node. Initially it's null, so there is no elements, no nodes in this linked list. And we have another nodes called the tail. Sorry, tail is small. and we can keep track of the number of elements n. And now let's implement the stack operation. In the stack operation we have two operations. The first one is the push, public void push operation. So let's push object x. Let's push at the beginning of the linked list. So in this case we have to do some steps. Let's go back to slides and see what we will do. So imagine you have a linked list like this, A, B, C, D, and you want to add a new node to this list. So first, head is pointing to A. We will make head pointing to the new node because the new node will be the new head, right? So head will point to the new node. But before that, we want to make e.next is the old head. So e.next should be the head, and then the head should be, the new head should be e. So let's write the code. So to push a node in the linked list, we have to create this node. Let's call it node n. The new node equals, no, we don't call it n because we have other variable with the name n. Let's call it node a equals to new node. So we created a node a.data is equal to x. So we store x in this node, and a.next, what will be the next node for this? This node that we want to push, the next node should be the head, okay, the old head. And after this we have to modify the head, so the head will be just node A, and then we will increase n, so we will increase the number of element. Okay, so with this we are pushing a new node in the linked list, and it will be in the beginning. Again, we create new node, we make the data as x, we make the next of this node is the head, the previous head, okay, and then the new head will be this node, and then we will increment n. Just in case this node was the first node, if n was equal to 0, we will make the tail also as this node, because previously if n is equal to 0, so the list is empty and I'm pushing the first element, this first element should be the head and the tail in the same time. So if this is the case, this also will be the tail in this case. So this is the push operation. Now let me do the pop operation. Public void, no, it's not void, it's returning object, and the name is pop. So for the pop operation we will delete the first element. So how we delete the first element? First we store the data. Let's call object x equals to head dot data. So we store the data of the first element because we are going to delete this element. But first, just we check if there was no such element, we return null, because the list is empty. If the list is empty, we don't return anything. Otherwise, we just take the data of the first element, and then we want now to delete this from the stack, from the linked list, yes, or the stack. So we said head equals to head dot next. So what we are doing here, we are moving the head to the next node, second node. So the second node now will be the head. And the first node is we cannot reach the first node. We will decrement n by 1 and we will return x. So we return the element that is stored in the first node. So with this, we will pop the first element. So again, we can push very easily. If you see, it's big O of 1, and pop also very easily, it's big O of 1. If you want to see how the pop operation is looking like, so this is the pop operation. I will just make the head equals to head.next. So it's pointing to this node, the head now, and this node is ignored. So this is the pop operation. So again, let's go back to slides. So this is the push operation, and this is the code that we write for the push operation, and this is the pop operation. We delete the first element in the linked list, and this is the code for the pop operation. We just forget, if we deleted a node, if the linked list has only one node, okay, and we deleted that node, in this case head will be head.next, but head.next will be null because it's only one node. So if I deleted one node, in this case, if after decrement of n the list is empty, I will make the tail is null, because now in this case I remove one element from n and n is not 0, so the tail should be null. The tail should not be pointing to that node that we remove. Head will be also null from this equation, so that's why we have to change the tail as well to null. That's in case the list is empty after the removal. Okay, to test this class, let's go to the main class. So now we can make linked list L equals to new linked list, and then I can do the push and pop operation. L dot push, let's push Haifa, L dot push Layan, L dot push Ahmad. So I'm pushing in the stack. Let me now pop and print what I pop. System.out.print ln l.pop. So in this case I am popping, I should pop last in first out. I should pop Ahmad in this case. If I pop 3 times, I pop Ahmad and then Layan and then Haifa. So the stack is working fine. So in this video we did a stack as a linked list and its efficient operation. It's big O of 1. Now we need as exercise to do this, to implement this linked list as a stack, and also we want to implement queue operation as in the linked list. So we want to implement add x, which add element at one side of the list and remove from the other side. So let's say we want to add at the end and we want to remove from the beginning. Okay, we want to add at the end of the linked list and remove from the beginning. So this is the exercise, and see you in the next video. Thank you.